Question 13. Two waves, P and Q, of the same frequency meet at a point in space. The amplitude of wave P is 2A0, and the amplitude of wave Q is 3A0. The waves combine at this point to form a resultant wave. For the resultant wave, what is the ratio of the maximum possible intensity to the minimum possible intensity? This question tests our understanding of wave superposition and how amplitude relates to intensity. Let's start by recalling what we know. We know that when two waves meet, their displacements add together according to the principle of superposition. That means the total displacement at any point is the sum of the individual displacements. We also know that the resultant amplitude in interference depends on both the individual amplitudes and the phase difference between the waves. Constructive interference occurs when waves arrive in phase and they reinforce each other, giving the maximum possible amplitude. When waves are exactly out of phase, they partially cancel each other, giving the minimum possible amplitude. Finally, we know that the intensity of a wave is proportional to the square of its amplitude. In other words, if the amplitude doubles, the intensity increases by a factor of 4. Now let's go through the solution step by step. The amplitudes of the individual waves are: wave P has amplitude 2A0, and wave Q has amplitude 3A0. For the maximum amplitude, the waves are in phase, so we add them together. Maximum amplitude equals wave P plus wave Q, which is 2A0 plus 3A0, giving 5A0. For the minimum amplitude, the waves are perfectly out of phase, so we subtract the smaller amplitude from the larger. Minimum amplitude equals the absolute value of wave Q minus wave P, which is 3A0 minus 2A0, giving 1A0. Since intensity is proportional to the square of amplitude, the ratio of maximum intensity to minimum intensity is maximum intensity divided by minimum intensity equals maximum amplitude squared divided by minimum amplitude squared. That is 5A0 squared divided by 1A0 squared, which equals 25. This is our final answer. What did we do? We wanted the ratio of maximum to minimum intensity. First, we found the maximum and minimum resultant amplitudes using the principle of superposition. Then, we converted these amplitudes into intensities by squaring them, and finally formed the ratio. Before we conclude, let's consider some areas of possible misconceptions. First, minimum intensity is not always zero, as some students may imagine. Destructive interference only fully cancels out the waves when the two waves have equal magnitudes. Also, students might add intensities instead of amplitudes, forgetting that it is proportional to the square of the resultant amplitude. Great job done. Let's summarize into the main points. Maximum intensity occurs when waves arrive in phase, giving the largest possible resultant amplitude. Minimum intensity occurs when waves arrive out of phase, giving the smallest possible resultant amplitude, which is not always zero if the waves have different amplitudes. Remember, intensity depends on the square of the amplitude, not the amplitude itself.